Hello and welcome to this demonstration of Ansys AIM. In part 1 of this tutorial video, I showed you how to set up fluid flow simulation for a car model at a single operating condition. In this video, I move from a single value analysis to a design point study to evaluate the lift and drag coefficients over a range of free stream velocities. Here we can see the formulas of lift and drag coefficients. Later in this demonstration, you will see how you can define these formulas in Ansys AIM. To start, I will identify the inlet velocity as a parameter. Next, I use calculated values in results task to define lift and drag coefficients. I change the method to user-defined expression and enter the expression that you can see on the screen. This expression simply calculates the summation of forces in horizontal direction and divided by the dynamic pressure and projected frontal area. To learn more about the details of fluid variables and functions used in this expression, please have a look at Ansys AIM documentation. Then I identify the drag coefficient as a parameter by selecting the P sign. In a similar manner, I define lift coefficient using the expression that you can see on the screen. I also define lift coefficient as a parameter. Next, I click on Project tab and double-click on Parameter Set. This opens up Parameter Set tab. Here, I can see the input and output parameters that I just defined. In Table of Design Points, I add additional design points to evaluate the lift and drag coefficients over a range of free stream velocities. And now, with a single mouse click, I can execute the entire solution for all of the design points that I have defined. The design point solution is now complete. I've solved for both lift and drag coefficients over a range of free stream velocities. Next, I'll go ahead and create a chart that shows the variation of lift and drag coefficients versus the inlet velocity. To do so, from Toolbox, I double-click on Parameters Chart. I can change the name of the chart here. And I specify the input and output variables on X and Y axis. From this chart, you can see as the inlet velocity increases, the drag coefficient increases as well. In a similar manner, I can create a plot for lift coefficient versus inlet velocity. I can also return to the study and review the results of any retained design points. I can select the design point of my interest and review the pressure on the car, for example. To recap, in the first part of this tutorial video, I showed you how to set up a fluid flow simulation for an external flow analysis on a car in Ansys AIM. In the second part of this demonstration, I used Ansys AIM to perform a parametric study to evaluate the lift and drag coefficients over a range of free stream velocities. I hope you found this demonstration useful, and thank you for watching.